Hello, my name is Henry Mathieson. I'm a freshman at Innovation Lab High School in Bothell, Washington. Today I will be talking about my changing of knowledge in physics class since the beginning of the semester. I will be showing my original ideas of topics, followed by my current knowledge and revised model of the original content. How objects become charged. Originally, I believe that three things can cause an object to become charged. These are connectivity, friction, and the creation of an electrical circuit. Now, through experiments and tests to determine what can cause an object to become charged, I know that static electricity causes objects to become charged. The three specific aspects are friction, conduction, and induction. This concept represents when two objects are rubbed together. Depending on the material, one object will become negatively charged, and the other object will become positively charged. When an object is negatively charged, it means that it has more electrons than protons. An object that is positively charged refers to it having more protons than electrons. In other terms, a negative object has gained electrons, and a positive object has lost electrons. The following assignment was one of the first in the semester. In this handout, we determined the charge of a balloon before, during, and after being rubbed with wool. In this assignment, my original thinking showed a simple representation of charge, using symbols to represent the total charge of an object. Before being rubbed, it showed both the wool and the balloon having neutral charge, represented using equal signs. During the rubbing process, this handout shows that the balloon and wool will become charged oppositely, meaning one becomes negative and the other one becomes positive. When the rubbing is completed, they maintain these charges. You may notice that there is text saying net charge. Net charge refers to the total amount of charge within an object. A proton adds 1 to this count. An electron subtracts 1 to this count. If the net charge is in the positives, it is positively charged. If it is 0, it is neutrally charged. And when this count is below 0 in the negatives, it is charged negatively. How can neutral objects attract charged objects? During our charge unit, there was one experiment in particular that guided the understanding of why a neutral object is able to attract charged objects. The following model represents an experiment we conducted to understand charged concepts. In this assignment, we placed two labeled tapes on top of each other, with the 2 tape being stacked atop the B2 tape. We then ripped these tapes off of a table, before ripping them apart from one another. The following model represents my initial ideas. It shows a simple representation of charge, only providing possible net charges. This next model represents my revised model. Yes, the tapes are neutral before being charged, as there is little to no static electricity applied at this point. Rather than being represented using equal signs, I represented an equal charge using both plus and minus signs. There are even amounts of both, meaning that the net charge is 0, which, as explained earlier, represents an object being neutral. The tapes after rubbing can either be represented like this, or using an inverted model such as this. To define which model is correct, you would need to bring the tape up to an object that is charged, and you know is either negative or positively charged. The T2 tape in the first model shows that it is positively charged, as there are more protons than electrons. The B2 tape is negative in this model. Overall, these tapes should have a total net charge that is roughly 0. You may be wondering why these would only have the rough net charge of 0. This is due to the fact that the table was also affected by this experiment, leaving it either negatively or positively charged due to its material. Why can't we create simple representations of ideas? Well, this handout explains just that. This model was originally incredibly basic in comparison to my current thinking. The reason why we do not use simple models like this is a little more complex and connects to the next idea of insulators and conductors. In an insulator, the negative charges, or electrons, are unable to move throughout the object. A conductor, however, allows these electrons to move freely throughout an object. In this example, the object, a styrofoam slab, is an insulator. The charges within it have no interaction with the charged object, as they are unable to move. However, if the slab were to be a conductor, let's say steel, the negative charges of the object would attract towards the other object, and the electrons of the charged object will repel from the uncharged object. Why is this? The reason that these electrons repel from the other electrons is due to a phenomenon called polarization. Polarization occurs when the electrons of a neutral object shift towards the protons of another object. This causes only the electrons of the charged object to shift away, as protons are unable to move. What is electrical discharge? The following model represents the idea of electrical discharge. My original thinking was that when the leg rubs against the carpet, your body becomes negatively charged. As you approach the doorknob, the negative charges discharge from your hand to the knob, creating a shocking sensation. This idea is also shown using lightning, where electrons transfer from either the ground to the clouds or the clouds to the ground. My current knowledge of electrical discharge represents a similar concept. This animation that I created represents a cycle that transfers electrons from the carpet to your body and discharges the electrons from your hand to the doorknob. What are domains of magnets? My original thinking of magnets was that the north and south poles of an object are similar to negative charges, being able to freely roam throughout an object. This model represents a similar concept to the charge unit. However, it uses symbols N, north, and S, south, rather than charges plus, positive, and minus, negative. My current thinking is that there are entities within an object. These entities have a north and a south pole, and can, shown in the following model, rotate around a point. A pole of this entity will attract to the opposite pole of a magnet. These two models show the entities in a magnet versus the entities in an unmagnetized ferromagnetic object. The term ferromagnetic object refers to an object that is able to become magnetized and can attract to magnets. A few examples of materials that are ferromagnetic are iron, cobalt, and nickel. What are scientific models and why do we use them? Scientific models are a way of interpreting evidence from observations that guide the future predictions of concepts. Scientific models can be an incredible source of information, where one can use gathered data to infer what may happen in a different scenario. After using and creating over 25 scientific models, I have personally used them to be a valuable piece of information when predicting what may happen. I think that they are even more valuable than the direct observation from an experiment, due to the aspect of prediction. I think this because of the need to infer why one thing occurs, which created all of the concepts in science. Some famous scientific models include the Bohr model of the atom, the DNA double helix model, Punnett squares in genetics, and the water cycle model. Thank you.